This is the second video for the first section of your McGraw Hill Geometry Textbook, Section 1-1. This will complete the notes for Section 1. And we're just going to go over some vocabulary here and then do a couple of examples of the problems that you're going to see in your homework. So the first vocabulary word of the year, the first official vocabulary word of the year is collinear points. Collinear points are three or more points, and we have to specify because there's through any 2 points there is one line. So we have to have at least 3 points that lie on the same line. Okay, the opposite of this would be non-collinear. So anytime we see the word collinear, it's referring to 3 or more points which lie on the same plane. Similarly, we have our second vocabulary term, which is co-planar. We define that as being geometric figures. These could be points, they could be lines, they could be shapes, which lie on the same plane. Co-planar, same plane. Opposite of that would be non-coplanar. You will see these words used in directions, and they will also appear on vocabulary quizzes starting relatively early in the school year. So using these words and using point, line, and plane, which we've already discussed, we're going to do a couple of naming examples. Now this is the first type of problem that you're going to see in this chapter. It is also going to be on the chapter test, as well as other items we do throughout the early part of the course. So here we have example 1, and it's asking us to name some things based on this diagram. So here in the diagram we have a plane. Notice the cursive P in the corner. Remember that we name a plane with a cursive capital letter. So plane P, which contains line N and points V, W, X, Z, and Y. Those points are all on plane P. There is another line passing through this plane that is not contained within the plane. See this part here where it's dotted? That's indicating that the line is coming down and passing through the plane, and we, quote, can't see it until it emerges from the bottom. But keep in mind that a plane is infinite, so in theory we would never be able to see this part of the line because it would all be underneath the plane as the plane extends out infinitely in all 4 directions. So the first one says, name a line containing point W. So here's point W. It is clearly lying on this line. Okay, so here's some example answers, and there are actually quite a few answers to this problem. First thing we could use is line N, which is the cursive letter there on the edge of that line. See it right there? Indicates that we can name the line with that lowercase cursive letter. Or we could use any 2 points on that line. So we could say VW, we could say VX. We don't even have to use W because W is on that line. There's a lot of other options. Now, it is worth noting that we do not have to use the line in the picture. There are actually several other lines that we could use. For instance, we could use the line WZ, which even though it is not shown in the picture, there is a line passing through those 2 points. Through any 2 points, there is a line. And if W is used in the name, then W is on the line. Similar, we could use T and W. That would also be another line that is not drawn in the picture, but that would contain point W. Second part says name a plane containing point X. Well, again, we have several options for how to answer that. There's no one correct answer. Makes these really easy to tell when you guys all work together. Let's say work together on the homework, is when you all give me the exact same answer, because there are literally dozens, well, at least a dozen different answers you could give here. We could say plane P. See the cursive P in the corner indicates that plane, which very clearly point X is on that plane. We could also use any combination of 3 points that are not on the same line. So we could say plane X, Y, Z. Look at those 3 points in the picture. X, Y, and Z are clearly not all on the same plane. We could say WXZ, so plane WXZ, same argument. Now in addition, just like we did with the line, we could name a plane that is not actually shown in the picture, but we would have to make sure if we're going to be adding something that isn't in the picture that we have to include x in the name of the plane. So we could say, for instance, plane x, y, t. That would be an example of another plane that is not actually shown in this picture, but that contains point x. So it's very easy to tell, okay, whether or not you get this sort of thing. Okay, next up, we have another vocabulary word, and that is the word intersection. Intersection is defined as a set of points which two or more geometric figures have in common. Now, let's look at a couple examples of this. First of all, when we have two lines that intersect, they always intersect at a point. So we would say x, point x, is the intersection of line L and line M. Anytime two lines intersect, they intersect at a single point, or they are the same line. So anytime you see two lines that cross, there should be one point that makes up the intersection. Now, on the other hand, when we have two planes that intersect, and this is extremely difficult to draw, when we have two planes that intersect, they always intersect along a line. So here we would say the intersection of plane M and plane N is line L. It is the line where those two planes cross each other, where they intersect. And there's an excellent visual I have for this, but I can't show you that through the internet, unfortunately, as I don't have a camera I can turn on myself at this moment. Imagine if you took two pieces of paper and you slit them and slid them together on the slits to create this picture. There would be a line on those pieces of paper that marked the intersection of those two planes. That does it for section 1 of chapter 1 in your McGraw Hill Geometry book.